Welcome to art class today, guys. We're going to discuss basic color theory today. So if we have white light and we pass it through a prism, it separates the colors and makes what we call a visible spectrum. And we are very familiar with this. It's the colors in rainbow order. And the visible spectrum appears to us when we pass white light through a prism in a bar like this, like a long bar. But Newton had the idea of putting it into a wheel. So this is where we get the color wheel. So Newton was a physicist, and his purpose in putting it into a wheel was that if you spun the wheel, then the wheel would appear as white if you spun it fast enough. But artists realized that what it did was put the colors in order of how they mix together. And so we use the color wheel for that reason. And there are a couple of things we need to know. One is that we have three primary colors. You guys know this. The primary colors are red, yellow, and blue. And we call them primary colors because we have to start with those. We cannot mix red, yellow, or blue from any other colors mixed together. Okay, the other thing that we want to know is that complementary colors are opposite of each other on the color wheel. So red and green are opposite, purple and yellow are opposite, and orange and blue are opposite. And we don't even have to remember what they are, because if we have a color wheel, we can just look at what's opposite. Now this is especially useful information, this idea that complementary colors are opposite, if we want to think about a color other than a primary or a secondary color and what is its complement. If we have a more complex color wheel, we could see, for example, that turquoise and reddish orange are opposite each other without having to do too much thinking. Complementary colors make each other stand out, but they also, when mixed, dull each other's intensity. Okay, so I don't have a slide for this, but I'm going to tell you, and I would normally write it on the board, that there are three characteristics of a color. One is hue. That is pigment. What pigment is it? We could say, what color is it? Color and hue are basically synonymous, but we're identifying the pigment when we're talking about the hue. The other one is intensity. So intensity is brightness or dullness of a color. And then the final one is value, which is lightness or darkness of a color. So we have hue, intensity, and value, and we can never get rid of any of them. All colors have all three of those characteristics. So value is lightness or darkness. We can look at this in terms of color. If we take a color and we add white, it gets lighter. If we add black, it gets darker. That's the simplest way to change value. And then we can also change intensity. We change intensity by adding the complement of the color. So if I have a blue, for example, and I think this blue is too bright, I just need it to be a little bit more dull, not so vibrant. I want to add orange, which is its complement. So if we go back here to our complementary color demonstration wheel here, we can see that orange and blue are opposite each other. And I'm actually going to have you, hopefully we'll have time to do an exercise where you choose two complementary colors and then you make them dull each other so that you can see that interaction. But this is critical information for color mixing. So we have this problem. Here's a color value scale. So if we take a color in the middle, and that's what these brackets are, this is the original color, and then we add white, we're saying that's a tint, and then if we add black, we're saying that's a shade of the color, so that's an additional term that we could incorporate here, but we can change the value of the color. Whenever we mix a color out of the tube, we are automatically going to dull its intensity. The most intense version of any color is its original pigment by itself without being mixed with anything. So this is one of the things that we need to keep in mind when we're mixing color, is that every time we mix something, we're automatically going to dull the color that we have. Okay, so here's a wheel that shows this complement mix, and you can see how these colors get less and less intense as we add the opposite color on the color wheel, or add its complement. And then we talked a lot about this. We've talked a lot about value being dark to light, and we have dark, middle, and light tones. And then of course we can do this to a color. We can take a color and we can make it light or dark. So we have value not only with black and white, but with every other single color in the universe. Okay. So why do we have so many colors? Because we can't paint with light. So the light spectrum and the color wheel, to some degree, is completely theoretical to a painter. Painter has to make paint out of something that he can find on the earth. So a rock or a plant, or maybe some kind of animal material. Earth, like actual dirt, can make pigment. And so we end up with a million yellows, a million blues, a million reds, and a million of everything else in between. And just because we call red, yellow, and blue our primary colors doesn't mean that those are that we can't find pigments out in the world that are secondary colors, because we find greens and oranges and purples out there in the world from a pure pigment. So this ends up being very complex, because if we go into an art store, we see a bunch of reds, a bunch of yellows, a bunch of oranges, and we say, well, what in the world? I thought all I needed was red, yellow, and blue, and I can make any color. Well, that's not exactly how simple it is, because we get these pigments from the earth, from some kind of earth material, and none of them are exactly like the red that we see on the light spectrum, and none of them mix with the other colors exactly the way we would expect if we only looked at the light spectrum. So that's why we have so many colors. And paint manufacturers know that people love color. They just utterly respond to it in the deepest part of themselves. And so when we see a bunch of vibrant colors, we get really excited. And when we go into a paint store and we think about, oh, my room could be this color, it's very exciting and hard to choose, right? So every color that you see at the art store, or that you see a bottle of paint of, is not necessarily a pure pigment. A lot of times these manufacturers will mix colors that they find to be exceptionally appealing so that you'll buy more paint. Okay, so let's talk about what paint is. Paint is a pigment, which is essentially colored dust. So we can make this from chemicals. We're very good at that in our industrialized age. But we can also find them from places in the earth. We can grind up stone. We can dry out plants. We can burn up plants and make them turn certain colors. But then we have to have this colored dust cohere. So we have something called a binder that we add to it. And the binder can be a bunch of different things. We can have water. We can have eggs. Egg tempera is actually, before the Renaissance, the main form of paint binder. Artists were mostly painting with eggs and pigment on wooden panels. We can have oil. Oil paint was a major innovation in the Renaissance, because oil paint technically never dries, and it's able to be very supple and great for blending really carefully. And then we can also have resins. So gum arabic is what I believe is in this picture, and that's what we make watercolor paint out of. It's water soluble, which means that it can be dissolved in water. Oil paint has to be dissolved with paint thinner. And then we get paint after we've mixed up pigment and a binder. And so this is very helpful for us to know.